All right. Welcome to this live stream of Engineering Trainer TV. My name is Luuk Hennen. I'm the CEO and founder at EngineeringTrainer.com. And today we're all going to have a conversation with Juan Manuel Mendez Franco. He's the COO, at Stressman Engineering and the president of the PSI Association. Juan has a ton of experience with pipe stress and related analysis techniques, both for very large scale projects, as we'll touch base on during this conversation, and also very detailed analysis techniques. We'll be discussing the importance of accurate stress analysis, pipe stress analysis in particular. We'll address topics like how accurate should you go for when you're doing a project, what to keep in mind when deciding the level of analysis detail. We'll touch base on how this is approached in different scale projects. We'll aim to roughly take, let's say, 45 minutes for this stream, but we might extend a little based on the number of questions and interactions that we get as we go along. Having said that, Juan, welcome on board. It's a real pleasure to have you on. How are you doing?
I'm very good today. Good morning, Luke. Good afternoon over there. I think it's already like 4 p.m. That's
Exactly,
like
late
4, 4,
afternoon.
4,
Yeah.
4, 4 p.m. in the Netherlands. I'm currently in Colombia. I'm in Medellin. So
All right.
I'm very happy to be here. It's always obviously a pleasure to spend some time with colleagues and people that it's interested in piping, which is, as you know, it's my passion. I love what I do. And well, I've been in this industry for around uh, it's been 17 years. I think time flies.
Oh, wow.
So it's 17 years now. I started with doing my it's a program that you do in Mexico called the social service, where you have to work in a company for 6 months in order to get your degree.
Right.
And I,
Like an
for whatever
internship, maybe.
reason, like an internship, for whatever reason, I started with Pemex, the national oil and gas company from Mexico. So I
All
was there
right.
for 6 months, and then I started working for some other engineering firms in Mexico, starting with UDE, a German company, then KBR in Mexico, in Singapore, in Indonesia as well.
Oh,
Then
really?
yeah, and obviously when you start traveling, it opens your mind and it increases that desire to learn more, to learn from other cultures, and obviously to learn from other people. And luckily, I think one of the most important things that we can talk about today is about that mentorship. When you get to know people that are really, really experienced engineers, and on top of that, they like to share the knowledge. I mean, you
Exactly.
can
Yeah.
you can grow
Yeah.
exponentially.
Yeah.
So
But yeah. I mean, let's not go too quick, Juan. We'll definitely get back to that. And I mean, you've been all over the place. I actually didn't know you were working. You've worked from abroad for a while. So before we really dive in, Juan, I would like to also invite and thank all the listeners out there for joining us today. Um, and I want to invite everyone that is listening at this very moment to, join the chat, ask questions, give comments, ask questions to me, to Juan, and just join the conversation as much as you can. And as always, I would like for every single one who's watching to share his or her location in the chat at this very moment. It's always nice for me and Juan to get some feedback of people who are out there, to get some idea of who we're connecting with. So please, take like 5 seconds to have a look at the chat in the YouTube stream and share your location. And as always, subscribe to the YouTube channel of Engineering Trainer TV and Stressman Engineering if this type of content is relevant for you. And please, by all means, reach out on LinkedIn to either myself or Juan. Connect with us, start a conversation, or just connect with us to stay connected for the future. We already have first few people jumping in. Edward, thanks for joining from Houston. Misab from Pakistan, awesome to have you on board. Vincent from Montreal. We see people from Belgium, so it's great to have you all on board. Thanks for joining. Um, Having said this, I mean, Juan, you kicked off straight away. Maybe we can talk a little bit about the company you work for at the moment before we move over towards the discussion about pipe stress accuracy.
Oh, that's perfect. That's a very good idea. So I'm gonna share some basics about the company that I represent. Stressman Engineering. It's a Norwegian company that has been in business for a little bit over 10 years. And I like to start sharing the four different business units that we have. Actually, five business units that we have. The first one, obviously, it's Stressman Engineering, where we execute projects. We have experience in, you know, mainly anything related to stress analysis, not necessarily just piping. We also do structural analysis, FEA, CFD, and some of the analysis. I'm going to talk a little bit more about that. We
Awesome.
have the Stressman Academy. Academy started around, I would say, 6-7 years ago, when Sondre found an opportunity to train people in Asia. I think the first time he went to South Korea. Sondre, by the way, Sondre is a Stressman Engineering CEO. He's my good friend, located in Norway, Porsgrunn. And then we start making training in Singapore as well. Unfortunately, as you know, when COVID hit, we couldn't continue with our training in presence or in person in Singapore. But now, obviously, taking advantage of these, the new technologies that you have, we partner with you, Luke, with our good friend from the Netherlands, with Engineering Trainer. We have a training called Piping Stress Fundamentals that you can access on this platform. I think it's 8 sessions of around 2 hours, if I'm correct. Correct me if
Yeah,
I'm
it's a
wrong.
total of 16 hours. Yeah, if people are interested, head over to engineeringtrainer.com, and it shouldn't be too hard to find the course. Yeah, I invite everyone to have a look. There's even a free preview available. Yeah.
Yeah, so you can have access to that training there. So that's the way that we continue with our academy. At the same time, we're also do some research and development projects along with some companies in Norway, along with I think with universities in Norway. I think the one
What
that we're closest to is the University of Southeast Norway, where
what
Sondre
type of
used to be
R&D are
part
we
of.
talking about, Juan?
I think they've been some specific research about some, you know, I don't know the details, to be honest, but it's something that has been done like in Norway
Hmm?
in more detail. And because sometimes it's research and development, you cannot disclose all that information
All
so
right, all right.
easily. But I mean, it's important, interesting projects for Stressman Engineering or for Stressman R&D. And well, obviously, it also helps us to get more experience in new technologies, in new projects. So that's the way that the Stressman also try to grow, having more challenges with this type of new activities.
Hmm?
Well, the other one that we have now, it's Stressman Marketing. For some reason, I think people liked our presentations. We have a uh, very nice brochures, in my opinion. Obviously, some people may
I
not like
agree.
them,
I
but
agree.
at
Yeah,
least
no, I
at
definitely
least I
agree.
like
Yeah.
them. And now we have a few clients. Thank you to our marketing director. His name is Iñaki. So in case you also need some help with marketing, we can help you with presentations, brochures, but only for engineering companies, energy companies, construction companies, because we are always going to have an engineer involved in your marketing design, which is important. It's not just the mind of a marketing guy, it's the mind of a marketing guy and an engineer. So that combination, it's something new that the Stressman is doing now. And at
Yeah.
the same time, and finally, we have Stressman Products. It's where we represent two companies in Mexico or Latin America. The first one is called Rilco Manufacturing. They design and manufacture piping supports. They have been in operations for over 50 years. And well, it's a company that we represent nowadays. The next one that we have is Corner Store Valves. It's a company where they have severe service valves, zero leakage, metal seat gaskets. They can help you to design your valve from scratch until the manufacture. You provide obviously all the different information that is required, fluid, velocities, the specific needs for your valve, and they help you to do it. It's not like an over-the-counter valve. It's more like a tailor-made valve that you can have. Well, now this is, like I said, a slide that I really love. We call it the Lego. When I talk to Iñaki, it's always the Lego. But here it shows in a very simple way all that the Stressman can do for a company. We can help now, as most companies around the world are moving. We're moving from just oil and gas industry into energy projects. In the middle, as you can see now, we have energy. We can do pipeline analysis, offshore projects, onshore projects. As you know, Norway, they have a very good reputation in the way that they execute offshore projects. They can do a lot of subsea piping as well, which is something that sometimes is complicated to find, and especially the companies that do have the experience, that have actually managed to perform this type of analysis. We can help with pressure vessels. In my at least I have worked in FPSOs. I have worked in different floating platforms as well, fixed platforms. We currently have a project related to vibration analysis. It's up here. We can also do that for a company in Gulf of Mexico, where they have two massive machines that are vibrating so much, and now we have to figure out what to do in order to reduce that vibration.
Those are interesting projects. Yeah,
interesting projects, because honestly, when you walk into the building, you can feel how this building is vibrating, and it's not just a little bit; it's vibrating a lot. So, I mean, it's interesting when you actually get to go to the site and see the support, see the pipes. Obviously, be there to give you a better understanding of what you do. Like we also have, help you with designing in storage tanks, oil and gas projects, subsea, like I said. Now we're going a little bit into the green energy, solar, eolic. We can help you with the CFD, FEA that may be required for your project. We can obviously support you on that and help you with piping design, a little bit more simple, but also quite important. When you have an experienced piping designer, it's gonna help you to, obviously to save time, materials, obviously manpower, when you can run your projects properly.
Right.
I think this is the last one related to Stressman, or two more. We have executed more than 370 projects around the world. Like I said, we belong to this organization that was founded 5 years ago, the PSI Association. You can also be part of it. We have a website, www.thepsiassociation.org, and it's a free membership. You can have access to some literature, videos. We have a YouTube channel. Whenever we make an event, we're gonna have one event soon, online.
Tell me about it. Yeah. I mean, I remember you telling me a few months back, that due to COVID, any physical, meetups were difficult and canceled to some extent. What is scheduled for the upcoming period?
Yeah, I mean, I think the last in-person event that we had was over 2 years ago. It was around these days in 2020. It was sponsored by a company in California, and we introduced to Houston this German software called ROHR, ROHR 2.
Right.
And it's also an interesting tool. Obviously, there are too many options in the market, but that particular time they were the sponsors of the event. And what we do is we like to have a company that comes over, sponsor the event. We have dinner, we have drinks, we have some networking time before the presentation. Then the company organizes or makes a presentation about their products. And after that, we have a technical presentation where I invite somebody well known in the industry that makes an interesting presentation about piping. It's always going to be like a vendor plus the technical presentation and more drinks after, or more networking. So we're planning to have something like that, but online. I hope to have it for next month. something similar to what we're having, but this
Awesome.
time through the PSI Association. I'm also part of I'm a committee member of B313. I'm very happy with this. It's honestly a big achievement for my career.
Yeah, congratulations.
When
Yeah,
yeah,
that's awesome.
thank you. When I started working in piping stress, I remember that I worked for this company called KBR, and I saw a guy had that was in the code, and it had KBR over there in the code. So now it's my name along with the Stressman Engineering. So to be part of the code, it's obviously an honor. I'm really happy, and obviously it's interesting to get to know these experienced engineers from all over the world that have been collaborating. They are the ones who actually wrote the code from
Yeah,
from from the very
how is that?
beginning.
How is that organized? Sorry to interrupt, Juan. How is that organized? I mean, you are part of a group. Like, how many people are there are in this group, for example?
Well, I mean, there are multiple groups. There is one for high pressure piping, for testing, for materials. I mean, the design group. I think design it's more related to piping stress. So
Right.
that's where I'm at. I would say in general there are around 20, 25 members per group. And now the interesting part is, as you know, ASME, American Society of Mechanical Engineers, is American. But now, obviously, they know that with the globalization and the experience that all the countries around the world have, now they are inviting more people from other countries to belong to the association. So, in
Right.
case you are interested on being part of this organization, let me know. Send me a message. You can have access to my email, jmmf@stressman.no. Maybe we can post something later, so you
Sure.
can contact me. And I'm also part of this international group. It's another subgroup within B313 where we invite people from other countries, specifically that are not located in the US and India. Why? Because the US it's the one that is managing everything, and then we
Right.
have India where they already have their own group. Because
Mm,
I mean there is a lot of piping engineers in India, so they have their own section. But if you are like in South America, for example, Europe, Australia, Africa, you can be part of this. Just let me know. I'll put you in touch with the right person so you can continue with the uh, getting involved with this organization. And
awesome.
just to finalize, we are also part of these two organizations from Norway. They pretty much help us to meet new clients. It's an interesting thing. I also encourage people to be part of associations, to be part of organizations. uh, from my personal experience, I can tell you it really helps you to grow as an engineer, as a person. It helps you to be more confident when you have to raise your voice, say something, um, and to learn from people. Obviously, the experience that people in India has, or the people in Mexico, or now that I'm in Colombia has, is different to the experience that I had when I was in the US. So it's important to be open, and there are opportunities all the time when you do the networking. So
Yeah, I agree.
I
Yeah.
I really invite you to be part of this. And well, just I think this is really the last one. We have the offices now in Norway, USA, and Mexico. Right now, I'm located here in Colombia. We have a rep in Italy and one in India. And as I said before, we used to have the academy in Singapore, and now the partnership that we have with Engineering Trainer, we call it the E Academy
Exactly.
in the
Yeah.
Netherlands. And just the last one now, this is really the very last one
No
related
worries.
to the hardware we have. As you know, to run FEA analysis, you really need to have you know powerful machines to run these type of calculations. We also have beam element analysis software, CFD, 2D, 3D modeling, FEA, and marine operation software. As I said, sometimes to get these licenses could be very expensive, because
Right.
it's not
Yeah.
just that you're going to get the license for one particular project. Sometimes you need to have a contract. So when you have those type of analysis that are not going to happen all the time, it's not worth to have a person in your organization to execute these projects. You can always subcontract companies. Obviously, we have a Stressman Engineering that can help you with that. For this particular analysis that are not going to happen too often in your organization. Even big companies, sometimes they do not do FEA or CFD.
Yeah.
And I'm talking about companies with thousands of employees.
Yeah, especially
Because
asset owners,
not
they,
worth
they
it.
tend to outsource that kind of work. Yeah.
So we can help you with that. Okay. And yeah, okay. Now the interesting part. It's an interesting conversation, I think, because more than a technical conversation, is more like common sense. I would say it like that. To understand very clear the definition of accuracy. And when I started to prepare this presentation, I found another interesting concept or word, precision. So combining these two versus time or versus the speed of analysis, you need to find that right balance to execute a project. Okay.
Right.
Well, now continuing with this, I guess for the people that are not so involved with piping stress analysis, maybe there are some project managers, maybe some executives that are not just related to piping. Why do we do piping stress analysis? Obviously, I would say that the main thing is because we need to make our system safe. There is nothing more important than safety, especially as engineering companies. It was new for some of the people. I remember that I talked to a guy that works in a bank. Safety in a bank
Right.
is not so relevant. They don't have all these procedures, all these conversations, meetings about being safe at work. For them, is they sometimes take it for granted. But we as engineers, and especially with this type of projects that we execute, we know that safety is so important. So
Yeah.
the first thing for a piping system is just to make the system safe, and not only safe for the people, but also safe for the environment. We need to take care of the ecosystem, and especially now, again, with these companies moving from just oil and gas, and that word that is sometimes not so welcome anymore, more like energy. We need to be careful. We need to be mindful when with our designs. And lastly, but not less important, uh, the economic. When you have a person that is reviewing, why do we have to have too many elbows in this system? Why is so flexible? Adding an elbow, maybe in a 36-inch line stainless steel elbow, I mean, it
That's
adds
a big
up,
deal.
because
Yeah.
it's not just one elbow. You may have 300 elbows at extra elbows that were not required. Excuse me. And now with an engineer, with supervision of an engineer, you can have a more accurate design. So those are the main things about piping stress. And this is an example of an accident that happened in in this platform.
It looks
It
awful. I mean,
is
that looks
and
severe.
yeah, it's not necessarily because of bad engineering. This one, I mean, I was reading about it. It was more like the maintenance was incorrect, and we are lucky that sometimes the incident is not because you made one mistake. It has to be a sequence of
Yeah. It
mistakes
often is. Yeah.
that actually trigger this explosion. And here there was a maintenance in a valve that was taken out, and then it was replaced with the blind flange. Later on, that tag or the comment for that maintenance was not put in place at the right location. So the next ship came, and they didn't see that comment. They didn't see that maintenance sheet. I guess that's the name. And they did another thing, and then the fire system also was shut down.
Right.
I mean, it was a sequence of different incidents that at the end, this was the disaster.
Yeah.
And you can also have a look at this list of pipeline accidents.
Yeah.
I
I
don't know if
didn't know that existed. I mean, it's
let
not a
me
fun
let
topic,
me
obviously, but it's very interesting
but
to read
but
about
but
those.
it's funny that look how many you have around the world. Here there are probably 200 different accidents related to piping.
Interesting. Yeah.
So I Googled a few days ago, and it's when I found that, yeah, there has been almost 200 incidents related to piping. So, okay, well,
I'll definitely have a
this
look. Yeah.
here, it it was a coincidence. It's funny. This is an accident that happened in Mexico. I think that is too loud. Okay, it's better now, right? So this was an accident that happened in Mexico last year, July.
Yeah, it's fairly
July
recent. I
the
saw these
20.
images. Yeah.
Yeah, I mean, they are quite impressive, to be honest, because
Yeah.
it looks like lava coming out from the ocean,
Yeah.
and
Crazy.
it was a gas leaking. And it was funny because that day, this happened in Gulf of Mexico, and that day I was in the Gulf of Mexico. And for whatever reason,
Oh
I
wow.
had a tour in a helicopter as well. One of these companies that provide services that take people from onshore to offshore platforms, they made me a tour. So I was flying when this accident was happening, and a lot of people thought that I was actually there, that I was having a look at this, but I wasn't there. I was, I don't know, 300 kilometers away from it, not so far, but I was in that region. So these are again more accidents that can occur because of poor piping analysis, or not because of poor piping analysis, but because of poor engineering.
Yeah.
So,
Yeah.
well, to continue, again, for people that are not so familiar with piping stress analysis, well, there are three different types of loads that are normally reviewed to verify the stresses on the pipe system. The first one, the piping loads. The primary loads. They are
Right.
related to the weight of the pipe and the internal pressure. Then you have the secondary loads that are related to the temperature of the piping system. And the last one are the occasional loads related to loads that may occur, but not all the time, such as wind, earthquake, snow, or when you have a PSV going off. You have to do analysis for that as well.
Yeah.
So
Yeah.
all these three loads combined, that's the way that you have calculate your piping system, and you design your piping system. This is just the very basics. I don't want to go into details. I guess like the ones that are already piping engineers, they already know that part, and the ones that do not know, well, it's just very simple explanation of what's involved in piping stress analysis. So this is the main part. I want to talk about this from a piping lead or a project manager perspective.
All
Okay,
right. Yeah.
so perhaps I would say the most accurate would be from the piping lead perspective. Project managers, sometimes they are not so involved with the technical part, but at least the piping lead, he needs to be. And
Yeah.
here we have to make some technical decisions in order to meet the timeline or the deadlines of a project.
Yeah.
So the
Yeah.
definition of accuracy, it's important because that's the degree which the result of a measurement, calculation, or a specification conforms to the correct value or standard, and essentially refer to how close the measurement is to an agreed value. Okay, so that's the definition of accuracy.
Yeah.
We have this graphic here, where obviously the faster you are in your calculation, the more speed you have in your calculation, obviously the less accurate, because people make mistakes. The faster you go on anything, it's just
And the less time you have to do detailed stuff, right?
that's correct. Or the less detail, like you said, things that you have to do.
Yeah.
You want to be more accurate, the speed of the project is gonna be lower.
Yeah.
It's gonna
Yeah.
take longer, but it's gonna be more accurate. And it's even simple with the machines. Like I said, you have this FEA analysis, this FEA simulation that may take a couple of days running. So you
Yeah.
run your calculation on Friday. When you come back on Monday, you get your result, because it's just time consuming. So it's important to find the balance, between speed and accuracy in a calculation. And obviously this is going to be reflected in quality of your analysis, quality. Specifically right now for accuracy, I just want to emphasize that this is more related to just one calculation, not multiple calculations, just one. Then here, another word that not too many people like, engineering judgment. Because, some people may think one way, and other people think in a different way. It's always a discussion, a little bit of back and forth. No, it needs to be this way. I have more years of experience. Oh no, you're just 5 years of experience. I think what I say, it's the truth. So we have to be, careful with this word, but at the same time to understand that based on the engineering judgment of each individual, we're gonna have to find the balance between speed and accuracy in our calculation. Okay.
How it's an interesting concept, engineering judgment. I mean, we run a training platform, so it definitely comes to the table every now and then. How do you teach people engineering judgment? Obviously, working a lot helps, but the big question is, how to speed up that process. Looking back at your career and the project that you did, Juan, like what would you recommend, like juniors or people in any point in their career to improve their engineering judgment, because that can be challenging.
Yeah, and I have the slide for this, and it's an interesting graphic that I found, this curve, where you, let's say at the beginning,
what do we see, like speed versus accuracy again, right?
It's the speed versus accuracy, yes.
Right.
But here you have this section that is the dashed line, or the dashed curve, where you have the low performance, and then obviously what you want to do is to go to high performance. It's just an offset in the curve where you are right here, and now you increase the speed, but increase as well accuracy. So instead of being in these values closer to the zero, now you're a little bit away of it. That you can have an offset. And then it's when we have this low performance versus high performance behavior in your or what you can do with your calculation. How can you change that?
Right.
If you have a more experienced engineer, at some point he was there, now he's here. Over the years, when you start doing something over and over and over and over, I think some people say that it's the 20,000 hours.
I heard 10 hours, but it's you hear these numbers.
Yeah, when you become an expert in something. So 20,000 hours, it's around 10 years, because each year it's around 2,000 of hours, at least in the US, considering 52 weeks and 40 hours per week, it's 2,080 hours per year. If you take the 2 weeks of vacation, 2,000, just to make it easy, 2,000 hours per year. So in 10 years, you become an expert in something. So with experience. And another one that it's more like, it's like a jump start for an engineer, could be the training. I think this is the most important, where you can really help people to to go from low performance to high performance. What can you also do? Training doesn't necessarily mean that you have to have a training session with him, I don't know, every week. No, it's so important, the mentorship. In companies that I work, sometimes you can be assigned to have a mentor. The mentor is going to be a guy that is a senior engineer or a senior manager that is going to help you, with guidance, what to do. I've done this project in other occasions. You may save some time when you do this, or you may need to do that in order to be more efficient.
Yeah.
That's why, again, what I was saying, when you start talking to more people, you get to know, obviously, more engineers within your organization, that at some point you may ask, hey, would you mind to help me with this? Would you mind to share a little bit of your experience? Instead of having lunch at your cubicle, maybe you can try to have lunch with someone, spend some time with him and build a relationship, and in the future maybe he can help you with something, with mentorship.
Yeah.
And obviously this, like I said, this is quite related to piping leads, that they have to be responsible of their engineers, of their team, and take care of the young engineers. I think if a young engineer is not involved in interesting analysis and in interesting simulations, he's going to be frustrated after a few months or maybe after a few years, and then he's going to try to go into a different career. When, again, in my opinion, piping, it's a very interesting career where you get to do too many different analyses, always different and new things. And for people that like to travel, that allows you to travel all over the world. For piping, we always have overtime, which is also important, and people love that. And well, that's why. Well, that's another topic that I love piping, but another
I
thing.
I know you, just to jump in on there a little bit. Did you have mentors in your own career, Juan? And did you make that like explicit? Did you ask for like how do you get to that situation?
Well, I would say that, I mean, there are I would say that there are different techniques. It could be sometimes like if you ask to a girl, "Hey, could you give me a kiss?" No, sometimes it's something that just happened. You're just start talking to them, then you become friends. When you see he's helping you so much, obviously I have so many. I guess one of them that may be there, Bob Zimmerman. He's also part of the association, PSI Association. He helped me so much, and because you also find these, you know, you get that friendship, but that friendship can also be escalated into a project when you can have a guy that could be more like a project manager for just in piping, and then you have a super technical guy that can help you with when there are very difficult questions or very complex calculations. Maybe this guy, the piping lead, is so focused on deadlines, on managing people, and then you have one guy that is super experienced and it's always helping him. Hey, I don't know what to do here, and you have a very experienced guy that it's also a good combination.
Yeah.
More like a technical a lead, a manager with someone else giving technical advice. That's a combination that I recommend for companies that when they execute mega projects. But like I said, it's something that you can talk in companies that are programs about mentorships.
Right.
I remember when I was with Foster Wheeler, that is now, I think it's AMEC or Wood. No, I think it's Wood now. Now they are Wood. They were
Yeah, a
Foster
lot of
Wheeler, then
mergers
AMEC
going on.
Foster Wheeler, and now they are Wood. Well, they have this program for mentorships, but like I said, feel free to talk to your supervisors, ask for these mentorships, and most of them are going to be willing to do it. I would say the other important part is to be focused on your calculation. When you are going to do something, if you have the instructions, usually it doesn't help you to be efficient, to perform well. Nowadays that you have your cell phone, that you're always, on Facebook or on Instagram or, different things, it causes mistakes. So less accuracy in your calculation. Obviously, that's important. Planning, that's so important. The way that you're gonna, perform your analysis. I need to do this first, then this, to find a sequence on your analysis. Now, as you know, projects, they are, running so fast. Back in the day, I think I didn't experience one of those, but it was more like a waterfall in the way that the projects were organized. When you started with process, then maybe a few guys from instrumentation and I don't know, pressure vessel, rotating equipment, then electrical, civil, piping, and at the end, piping stress. We're always at the end. But now everybody wants to do everything at the same time. It's more like it's like this room,
going
instead of being like this.
Like being in sequence to like everybody has to start straight away, like more in parallel.
Yes, and that's so important because it's something that affects accuracy so much. Mhm.
Yeah.
So let's continue with that. So, these are some strategies that you have to, go from low performance to high performance.
We got an interesting question, and I think it's related to this slide as well, Juan. So let me just address it. First of all, Ahmed Ali, thanks for asking the question. Thanks for joining the chat. Ahmed asks, how can we make the balance between speed and accuracy? I mean, you already touched upon it's hard to have it both ways. Maybe we can touch upon that topic during this slide, Juan. So as an engineer, how to make that balance between speed and accuracy, how to make the decisions for details.
Well, that's something that I'm gonna talk about a little bit later,
All
but
right,
but
all
it's
right.
it's a very good question because,
Yeah,
and I think that's the most important question because there are so many variables to see or to know what's the right balance between speed and accuracy.
exactly.
Uh, okay, I don't know what I did. Okay, here we are, and this is the other graphic that I have. This graph is quite interesting to me because I mean I didn't pay attention to this too much, but this is something that affects projects, not just one
Help me out
calculation.
a little bit, Juan. What exactly are we seeing on the axis?
Here is oh well, I think we didn't have the I forgot to have the but this is like the accuracy, or this is the correct value. This is the correct value. This dashed line that you see here.
Right,
This
right.
is, I don't know, for whatever thing you are talking about, this is the correct answer. This
Hmm,
in dashed, this vertical line. Uh-huh.
hmm,
And then these are all the different uh, uh, responses or results that you can get from a calculation. Okay,
right.
so this is quite important because accuracy may only affect one calculation. You can be inaccurate in one calculation. The problem is when you are unprecise with your project, with your calculations. And how can this happen when you set the rules wrong from the beginning? So all your results are gonna be off. Not just one calculation, but if you set your piping specifications incorrectly,
Hmm,
and now every calculation that you do, instead of being here, everything is gonna be off. And maybe later on you actually have to redo all your calculations. If you already perform 20 piping stress analysis, now you have to do them again
yeah,
because
yeah.
you had the incorrect input from the very beginning. So the precision is the quality of being exact and refers to how close two or more measurements, let's change these, two or more calculations are to each other. Two or more results are close to each other,
Right.
regardless whether those measurements are accurate or not. Okay, so it's important to understand that accuracy and precision is different. So we have this chart here where we have this curve in green. This is precise, not accurate. Precise is because, as you can see, it's not so wide. The values are within this range,
Hmm,
and but the correct result is kind of far. There is an offset from here to here, you know.
right, right, right. Yeah.
So it's not accurate, but it's precise because everything is kind of like in the same location. This is, for example, when you have incorrect piping specification, or that somebody says, "Hey, the site conditions of this place, we're not gonna have earthquake," for example. So you do all your calculations without earthquake, and later on, oh, there was earthquake. So now you are right here.
Hmm,
All your results were kind of accurate, or I'm sorry, precise, but inaccurate. So then we have this other curve, the one in kind of red. It's inaccurate and imprecise. As you can see, it's quite wide. So the results are all over the place, and at the same time, you are off this distance. Then you have this black curve, which is the accurate but not precise.
hmm,
Yeah, this is the correct result, but it's so wide, from here
yeah,
to
yeah.
here. This is really not accurate. And then you have a Stressman orange color, where we are accurate and precise.
Exactly.
That so this is so important because now it means that you have accuracy and you have precision. Accuracy in one calculation And when you do that for multiple calculations, now you're being precise with your project, So I think that's uh, that's interesting. And now here we're coming to that section where it may address Ahmed's question. And we need to understand this is not a science project. When we do piping stress analysis, when we execute a project, we are not doing a science project. We have a limited amount of hours assigned to each activity, eventually to a project that we need to get things done fast pace. It needs to be like that. And here are very complex analysis, some R&D that we have done for what we do in piping stress. I would say that 90% of the analysis are not so complex analysis. Obviously, there is analysis with the compressors, reciprocating compressors, vibration, dynamic analysis, where obviously you need to have um, more experience and you're going to spend more time. But we need to understand this. This is not a science project. Mm-hmm. Let's go to the next slide. Okay, this is the stage of the project. This also helps to address Ahmed's question about how can we find the balance between speed and accuracy.
Exactly.
It depends. One variable that we can have into the equation is the stage of the project. Let's say for piping, they are normally going to get involved in pre-feed, feed, and detailed design. I remember the very first time that I worked on a pre-feed project was Cameron LNG. That was back in 2000, I think it was 2012.
Right.
And it was the pre-feed for this project that I eventually work again in that project, but in the detailed design stage. So in pre-feed, I remember that I made some simulations. I did some piping stress analysis, but we didn't even have the correct location of the equipment. I remember that I did some compressor calculations, but it was more to know that the system was a little bit flexible, that we could have the proper elevations between nozzles, sometimes especially for large bore pipe, like in the ones that you can have in a LNG project, the elbows, sometimes when you try to go down, because it's like 1.5 times the diameter and you have two elbows, it's 3 times. But in a 72-inch line, it's a lot of space. So
that adds up.
if you set your nozzle elevations incorrectly from the beginning, then later on, how can you fix that? Or if you have the slope of the flare system without the correct elevations, it's also another problem. So you see the analysis from a different perspective, where you need to understand the goals of your analysis. This time is not that you need to qualify your allowable loads like 100% correctly or accurate, because it's not so important. We're in a pre-feed stage where we kind of want to know, maybe how many elbows we're going to have in a project to get the MTO of a project. Those kind of things. Then in feed, obviously, it's a little bit more accurate, but not so much. Some people don't even have the pre-feed and feed. It's almost the same.
Yeah, exactly.
It's just the name of it. And then you have the detailed design. Obviously, right there, it needs to be much more accurate. So, like I said, there are too many different variables into the equation to know when a project needs to be more accurate, or the calculation needs to be more accurate, and there needs to be precision in our system, in our project. So I think that also helps to understand that the reason behind, and to try to find that balance. Mm-hmm.
Yeah, and I think this topic is an interesting one. I mean, here you can go, like, if you start adding FEA to, your pipe stress analysis, I mean, you can go all crazy with levels of detail. Yeah.
Yes, of course. And I would say one of the reasons to have this BIM element software such as all the piping stress software that we use, is that the calculations that we need to do are not needed to be so accurate, so precise as if you have to do it with FEA, because it's gonna
Right.
take longer. I
Yeah.
cannot imagine to model a piping system, a complete piping system that you can run, let's say for example with CSR2 or with AutoPipe in ANSYS. It would be
No,
crazy.
that would be crazy. Yeah.
I think you probably can't even run it because it's gonna be too heavy. So it's important to understand that, but here again, it comes to engineering judgment. And obviously, when something fails, I mean, you run your calculation, you cannot meet the allowable loads on a pressure vessel, for example.
Yeah.
You can add flexibility to that joint between the shell and the nozzle of in your calculation. If it fails, you can also do another analysis, WRC. If it fails, you can even go and try to do something with ANSYS, for example.
Yeah. Yeah.
So, but it's like stages. You don't need to go from the basic one. When you have a table, okay, the allowable load in this direction, Fx, it's 300, Fy 500, Fc 200. As long as you are below this, obviously you also have the moments, moment X, moment Y, and moment Z. If you are below that, you are fine. That's enough. You don't need to prove that with an FEA calculation. Okay,
Yeah.
so
Yeah.
it's important to have that, and obviously for the companies, they need to start preparing those allowable load tables and have them in their specifications or in the standards of each one of the engineering companies around the world. Okay.
Yeah. It's interesting to see, Juan, just to add, like in the chat we see some conversation going on about experience, that experience of the pipe stress engineer is key to make those decisions, how deep to go, from beam element to WRC, or even to FEA. I thought that was interesting to just add to the conversation. I mean, it's obvious, but to me and to engineering trainer, and this, the big challenge is also, how can you speed up the process of an individual to get this experience and the associated engineering judgment. But we'll touch a little bit on that later on. I would have to add, Juan, I mean, time flies. It's no worries. It's 5 or 7 minutes like in 7 minutes we're talking for 1 hour. And I know we still have quite a lot of slides to available. So let's just pick up a few more topics, and maybe wrap it up in let's say 10 minutes or so. And
Yeah, that's fine.
if we feel like we have too much slides left, we'll just schedule a part 2. I would say.
No, that's fine. That's fine. I'm gonna try to go a little bit faster. But for example, on subsea piping, I'm not experienced in subsea piping, but this is something that I learned from Sondre. In subsea piping, it's a more, detailed analysis. It's subjected to more stringent codes,
Hmm.
and obviously, it's not the same to design something for that is going to be here for example, in Medellin, when you have a very nice site conditions.
Exactly. Yeah.
The temperature is never going to change. Is not so windy. If I'm not wrong, I think there is no earthquakes here. Rather than to have them at the bottom of the ocean,
Yeah.
it's
Yeah.
it's just completely different design. So for this one,
Yeah.
you have to have, for example, your structural analysis and then your piping analysis. Here, you're gonna do an interface between these two, where you're gonna, send loads to the structural calculation, and then from those loads, now you recalculate your system, and now you provide the stiffness values to the restraints that you have in your piping system, and this is gonna be an interaction at up to the point where the values are not changing too much, where
Right.
they are
Yeah.
kind of like start to
Converging. Yeah.
balance. At the beginning is like this, and at the end they're gonna be like. And then with these loads for specific sections or specific components, you need to have FEA analysis. It's just the requirement. And for example, on piping, you also have to do this hydrogen-induced stress cracking as well, which
Yeah.
is another a complex calculation that you have to do. And there is no other option. This needs to be a more precise simulation and it's the way it has to be. Here we cannot play games in terms of maybe I don't need to do FEA, or I don't want to do it. No, you have to. There are things where it's more important, it's more stringent according to the codes or regulations, or sometimes even client request that you have to do it. Okay. So to continue with this, again, some of these topics here are not necessarily just affecting the accuracy in a calculation, but also the precision in a project. But this could be, for example, a stiffness near rotating equipment. We know that when you perform your stress analysis and you're going to be working near to a compressor, for example, if you don't add the stiffness in your restraints near the nozzle, you are assuming that they are going to be infinitely stiff, which is not right. Here you're going to have little deflections. For example, you need to check the alignment in your compressor. This, when you work with this type of analysis, the accuracy is so important. You cannot make mistakes. So again, the more accurate input, the more accurate output. If you have bad information at the beginning, there is no way that you can have good output. It's just like that. Everybody knows that. Okay. So assumptions as well. It's something that, obviously, because of the nature of the project, the speed of the project, the deadlines, you have to start a calculation without having all the information. And this happens all the time. Oh, I got a phone call.
We got somebody connecting with you on this.
Okay, so you have these assumptions that are going to happen all the time, and you have to live with that and learn to use your judgment for this and say, here I have to do this, I can do that. But with the experience, with the years, and also with guidance from your piping lead, you can do that. The nozzle stiffness, it's something that you can also use in your system. Instead of having heavier loads, you're gonna add some flexibility to your nozzle, that it's gonna reduce the loads.
I mean, I remember Juan seeing like anchor points used as boundary conditions at nozzle locations, right? I mean, if it works, I guess it's the most easy from a modeling point of view, but often you get like these like nozzle load clashes, as anchor points give way unrealistic high loads.
Yeah, and like you said, there are cases where that's enough. With all these the safety factors, which is another point, the safety factors that are taken into account when a pressure vessel is designed. Using the allowable loads from a table or the ones from the vendor, that's enough. Again, if you cannot qualify that, you can add more flexibility to your system. Maybe adding a loop or adding a spring or something to reduce the load on your nozzle. But sometimes you are like, I mean, it would be ridiculous to add a loop here, for example, or there is no space to add that loop, or just it's difficult to install a spring, let's say. Then you can use this option. Now let's try to go a more accurate simulation where we can do the Nozzle Pro, for example. Nozzle Pro is another like FEA software oriented to nozzles, for example. So you can use that software, and then you see, the allowable loads that I have are exceeding my allowable loads from this table that I have from my engineering firm, but they pass Nozzle Pro. So there are different ways to qualify your system. Obviously, at the end, you need to get approval. I mean, sometimes even if you have your simulation in Nozzle Pro, that you still need to qualify it according to your vendor. But that's another topic. You also have this V31.3 versus the V31J, which is the SIFs and the flexibility factors that you can have in for example, in an elbow.
Right. Yes, stress intensification factors. Yeah.
Back in the day, they were the factors were not so accurate. Were more like a simple formulas, and now they are more more developed equations for these. And there is an example that it's a piping system that it's overstressed when you are using V31.3. When you use V31J, it passes. So, I've seen those. It's not that it helps to qualify the systems. No, it helps you to have a result more accurate. That's the reality. In some cases, a system that according to B31.3 was okay, now with B31J may fail.
Yeah. Yeah.
So it's accuracy rather than to help you or not help you. Okay. So the column temperature profile, that's another important one. Is, for example, when you have a column just like this one here
Right.
in the picture, that obviously, and then you want to know what's the vertical displacement that I'm gonna have here in my nozzle. Oh, it's gonna be almost impossible to calculate the correct one because you don't really know all the internals here and the temperature, how it's distributed from the top to the bottom. But you can calculate it and get something kind of accurate when you have all the lines, sometimes even major lines. You know that there is a 12-inch line, another 16, another 14. At the top you have a 24. You know that the 16 is 20. The next line it's 15. The following it's 24. It's 100. And then you kind of calculate an average. It's called a temperature profile. Something simple, and then you can calculate the vertical displacement in your column, instead of having to do something crazy, trying to like a science project to calculate that thermal growth.
Yeah, and it would also, I mean, what just thinking out loud, it would also be like a quick exercise to, I mean, you can put in like the design temperature of the column, which gives the complete maximum value, theoretical value of the vertical displacement. Also very, very conservative, obviously. But if that is, that approach is giving problems, then adding this profile, or at least looking into this profile briefly and seeing, does that totally change the nozzle loads? Interesting approach.
Yeah, and that's correct when you use the design temperature, because normally in pressure vessels you have to qualify your nozzles for design temperature. So, but then you can have two different column profiles. One with everything at design temperature, using design temperature in your line, but you need to have another one for operating. So that's when you make those breakdowns in your column. And well, that's another slide that I have, but that's related to that design temperature as well. Well, stiffness, when you have a restraint, or for example, when you have elbows that have a flange right next to the elbow, it makes the elbow more rigid. So it changes the flexibility of that component, as well with the supports. Piping modeling as well, how the distances that you have may be incorrect, they're a little bit more, a little bit longer, a little bit shorter, can obviously change the accuracy of a calculation. Okay.
Yeah, and I would also like to add, I mean, the level of detail in these models, right? Adding steel or like gaps, obviously. Those are all, those are decisions that designers have to make before iterating towards their results and their reports.
Yeah, like we have this other one. I mean, this is really coming from the piping lead, when he decides at the beginning, for, I don't know, 16-inch lines and below, we're gonna add 5% of additional load for our spring. For components that are not taken into account in the calculation. Let's say that you have shoes. The shoes have a weight, I don't know, maybe a couple of 100 kilograms, that are not taken into account in the calculation. So you add that additional weight. Some people say, okay, but for larger than 16, we need to add 10% because the shoes are heavier, are bigger, or the trunnion. You didn't take into account the trunnion and the base plate of the trunnion. Different things that at the end we can be as accurate as we want, but for things like this, obviously we need to be mindful that maybe a massive pipe with a massive plate, it's obviously going to go from a spring that is probably a size 20 to a size 21, for example.
Right. Yeah.
So just remember that part, as well with the weight. This is also something that happens at the beginning when there is no information from your valves, and you just have to make an assumption. Like some people say, okay, if you have a control valve, what do I do when I don't have any information? I may probably have the valve weight, but I don't have the actuator. Some people say just do it 1.5 times the gate valve
exactly.
weight, and that's it, and go ahead and start your calculation. So those kind of things are things that we have to do just to to run our calculation. And it's, for example, if you have two rigid supports right next to it or on each side of the valve, if this is 300 kilograms or it's 400 kilograms, you have your rigid supports right next to it, it's not a big deal. If you have springs next to it, then it's a big deal because it may not work. So we need to look at the whole thing. It's not, again, this is not that we don't have to work our piping calculation as a science project where we just look at those little details. We need to see as a whole perspective of the project, of the whole perspective of a calculation.
Yeah, I just like to jump in. I mean, there's an interesting, conversation going on in the chat, which we could address maybe a little bit. Is I mean, things are mentioned about cost savings, focusing on cost savings rather than accuracy. We also saw some comments related to depending on the cycles of the market, that companies let experienced people go, and having to hire new hires and juniors when the market picks up. So I mean, those are all trends that I get, at least I've seen happening indeed. And there's one comment, Juan, about someone is commenting related that in some projects the design and the stress is done by the same person, right? So you don't have like these departments, which I find an interesting comment. I mean, I haven't been involved in these projects myself. Not sure if you have, Juan, but that's an interesting comment.
Yeah, well, I've never been in a project where the piping designer is the same than the piping stress engineer. Not really. I haven't seen anything like that. I think it may happen in a small project where one guy is good enough to do the piping routing for a 3D model, but at the same time he knows piping stress. I would say that now with younger generations, they are very very good with the computer, so they can easily learn smart 3D or older software like PDMS, PDS, and at the same time they can run a calculation because they have an engineering background. As I would say that back in the days, most of the piping designers were not engineers. I would say the engineers that are or the piping designers that are retiring now, they are not, most of them, engineers. Now that is changing so much. There is so many piping designers that have an engineering background. Right. So, and I know piping stress engineers that because of their experience, even that they didn't have a bachelor's degree, they can run a calculation and they are very experienced engineers. At the end, one thing is what you learn in school, which obviously gives you the foundation of as a mechanical engineer, civil engineer, or in my case, I'm a mechatronics engineer. But there is a lot more that you have to learn in school. There are not so many schools or not too many colleges, universities around the world that teach piping stress. Sondre, he was teaching piping stress in University of Southeast Norway. But that's one of the few ones. There was a class about piping stress, but there are not so many. So that's why it's a little complicated. But yeah, I mean, it can be done. If you have the knowledge, you can do piping design and piping stress as well.
Interesting. Comment.
So again, the engineering judgment when we're gonna execute a project one way or another, And here, like I said, when we have engineering judgment, we can there are certain activities that you can have for this. For example, to qualify a piping system, once a piping system hasn't changed, when they do maintenance or modification or replace a component or something, and the routing hasn't changed too much, just with an experienced professional, he can qualify, that piping system without the need to have to run a piping stress simulation. So that's when the engineering judgment comes into play. For example, here again, so many people talk about the friction and the gaps.
Here we see the
These
gaps.
are
It always pops up.
non-linearities that we have in our simulations. And to be honest, I had a project. It was a project where it was from the very beginning, and our piping lead was very, very strict. It's a good friend of mine. I'm not gonna say his name, but he decided from the beginning, we are gonna run this project with 0 gaps, no gaps at all, the whole project, no matter what. It was a compressor system where you just need a little bit of gap, maybe 1 millimeter to qualify your nozzle. No way, 0 gap. He said it from the beginning. He set the rules like that, and we have to do it that way. At the end, we don't know what's gonna happen in the field. He said, it's just that we don't know if we're gonna have the gap. The 3 millimeters, maybe they're gonna have 5 millimeters, maybe they're gonna have 10 millimeters, or they probably forgot the gaps. So we're gonna run the calculations with 0 gap. On the other hand, we can have everybody running the calculation with 3 millimeters gap for each one of the restraints, which is what you have in your piping support drawings, 3 millimeters or 1/8 of an inch, and it's gonna go all across the project, all over. But at the same time,
have you seen like projects doing both and comparing them?
No, because that
work,
could be the option. That could be the option. Now you can run one calculation with 0 gap and the other calculation with 1/8 of an inch. But again, one more time, this is about accuracy. Is this really important? Maybe not. We don't really know what is going to happen in the field. To be honest, when you go to the field and you see these massive lines, you see all the, how the environment affect the pipes and the supports, the corrosion, the dust, sand in some places. This 1/8 of an inch or 3 millimeters, it really means nothing, to be honest. So making a big deal about this sometimes, I mean, it really depends on each engineer perspective, the engineering judgment of each engineer. And it's a topic where we can discuss, and maybe people in the chat are already talking about the gaps and the friction and that stuff. I mean, we really don't know. Some people say that the friction between steel and steel should be 0.4. In other projects, it's 0.3. For me, I would always use 0.3 because it's a factor that's going to lower the loads. If you have 1,000 vertical, now the friction is 400 instead of 300. So I would always use 300 for my benefit. But some people think, oh no, you shouldn't use 0.3. You have to use 0.4. So different things about accuracy. Here again, the static and versus dynamic analysis. Do we have to do it? We don't have to do it. Like a few months ago, we have a request for quote. At the end, I'm not sure if we executed that project, but this company wanted to have a time period analysis for just for thermal expansion. It was gonna be cyclic because the system was gonna be heating up and cooling down, but it was gonna be in a long period of time that really you don't need to have a dynamic simulation for that. It was just considered as a static analysis because at the end the system was, I would say, always in equilibrium. You didn't need to have this type of dynamic analysis. So here, like I said, again for precision, and this is just to finalize, I would say bad decisions from management. Why? Because sometimes they say, let's run the calculations without having the information, and then what's going to happen? The whole project is gonna go wrong. Maybe for a specific, let's say in the line list, you have that all the LNG's lines are gonna be at minus 200 Celsius, for example. When the line list is issued, they say, oh, we decide that it was going to be minus 260.
Yeah, exactly. Yeah, nothing is more frustrating than design pressures or something being changed late in the project.
Now all your calculations need to be updated.
Exactly. Yeah.
But I know that, I mean, not necessarily bad decisions, but it's just, again, the projects are time driven, and you just need to, it's like a gamble, you know? It's like flipping a coin. It may work, it may not work. You take the risk. The managers, they do that evaluation to say, okay, we don't have this information, but based on the experience of our engineers, they said, okay, we can run the analysis with this poor information, but with our experience, we can make some assumption that may be accurate. Okay, go ahead. That's why it's important when you have experienced engineers to run your projects, to manage your projects, because they from other projects they already know, and now that you have poor information, bad information, they can make decisions and make
Yeah.
the project happen. Okay, so again, one important, the incorrect site conditions. From the very beginning, you have your site conditions, or let's say this for us as piping and stress engineers, the config file, which is the file that is used in CSR2. When you set that file at the beginning of the project, and then you share that file with everybody working in your project. Nobody should change this file,
Yeah.
because everybody's going to work with the same, the same configuration. If you make a mistake in this file, that a factor that was not the best, and now all the calculations
Yeah.
were running according to this, boom,
Affects
now
everything. Yeah.
you have to update your calculation. Another important one is this: design temperature versus flex temperature. That's the one that you talk about. You mentioned that the condition at the beginning. There are companies where they use this design temperature, but design temperature could be the something very unrealistic, something that
Right.
may never happen, that your system is never going to experience. But now you also have this flex temperature. The flex temperature, some companies have it, just like I remember with KBR, they had that condition: flex maximum and flex minimum.
All
Flex
right.
maximum and flex minimum were always a little bit below the design temperature and a little bit above the minimum design temperature. But it was more like, this is for piping stress. Don't give
Okay.
them something that is really never going to happen. Unrealistic conditions. A very common one is, for example, in a flare system. In an LNG flare system, there are lines that are, little lines going into my flare, and the lines can be minus 260. But the
Uh-huh.
flare, it's a, I don't know, 24-inch line. So these little lines, discharging into this massive line, are not going to turn this massive line, into a minus 260 as well.
Mm.
So, but here is, again, it's a little bit more, it's a little bit more complicated system, because it's a minus 260, that line. But also, if you can ask process, hey, could you give me the actual temperature? It's going to take them time as well. So we
Yeah.
need to understand each other and work as a team in a company and say, okay, I'm just going to do the calculation with minus 260, because for process to calculate the temperature that we're actually going to have in this section of my flare, it's just going to take them forever. So
Yeah.
just go ahead
Yeah.
with your minus 260 and be done with it. Those are the things. At the end, it's a project, and a project needs to be worked as a team.
Yeah.
It's not that,
Just, I mean,
oh,
just to be like, we're talking Fahrenheit here for everyone, just to be absolutely clear. Um, Temperatures, minus 260. I mean, that's Fahrenheit, I would suppose.
yeah. But like I said, it's I mean, those are interesting calculations, and again, we have to work as a team. That's the key to make the project successful, to make that calculation as fast as possible, and continue like that. The other important one, it's a pre-checking and feedback. Here again, it's also related to mentorship. You, as a piping checker or a piping super checker, which some companies have, or the quality control guy, QA/QC, in some companies, they have this position. If you don't provide a good feedback to your engineer, to your junior engineer, he's never going to learn. There are some guys that are, so quiet, they don't want to talk too much, and they don't come and have a conversation with this guy. Hey, you need to do this. You're making the same mistake over and over. Please don't forget next time that you have to have this specific condition in your piping system. It's important, that feedback all the time, because at the end, that the feedback is what helps something, to grow, to be better. If there is no feedback, you may continue thinking that you're growing like this, but you're actually going in the other direction.
Just to jump in here, Edward made an interesting comment. It relates to feedback as well, but more on like between departments. He writes, process engineers create the stress problems with unrealistic conditions, smiley face. Always need to be ready to challenge them and understand how a system is going to really operate. I think that's a very fair point.
And that's correct. And that's why it's, again, important to have these conversations within the organization, within the project. As you know, there are piping systems where you know that you're gonna have some sections of your pipe at a specific temperature, when the other section is at a different temperature.
Yeah.
And then it could be the opposite. When you have, for example, a spare pump, or you are going to have two pumps running at the same time, so that's operating temperature, and the other one is on standby. We, as engineers, need to have that conversation with our process engineers, to understand what is actually happening in my system. Instead of just, I have the temperature from the line list, that's what I'm going to run. No, you have to have that conversation. Take the time, to like I said, what we have from low performance to high performance, to plan. You have to plan how you're going to execute your calculation. I have all my line list, the line list conditions for my system. I have my piping specification. I have my piping standard supports in hand. I have my piping stress highlights or piping stress specification. And then I have all the information. Now let's go and start. Instead of going like crazy without having all the documentation, having my pin IDs, access to everything, making sure that you always look at the latest revision of your line list, latest revision of your pin IDs, but you need to do this in an organized way, with order. Otherwise, that low performance is never going to go to that high performance. And just, I think one more, it would be the codes and standards. The codes and standards, they help to understand or to direct a project, to organize a project. That's why, so people do the things the same way, and not I do it my way, you do it your way, and the other person do it another way. That's why you have the standards and codes.
Yeah,
it's important to know.
Juan, sorry to jump in. We're running well over time, which is, we can go on for hours. We did this in the past, in private. Let's select one or two slides, Juan, which you think you would like to address or discuss some topics about, just to move towards wrapping this thing up. We have a fair amount of slides available, I believe. I think that would make sense, right?
Yeah. Well, just for this particular one, I would say that obviously identify the nature of the project. One thing is what you're going to do in an onshore project and another offshore project.
Right.
It's the same with above ground, underground, subsea piping. You know which one is more stringent than the other. Just keep that in mind. Obviously, keep in mind that a stage of the project, it's a pre-feed, it's a feed, it's a detail engineering section, and you have these codes and standards that you have to follow. That's what they are for. You have this standard, for example, from Equinor. You have these codes, DMV, ASME, which they are not just for the organization, but also for the government. They need to be approved. They need to be qualified. So you have to follow those codes. So here, there is no exception. You have to follow those codes, and you have to follow the standards. That's important. Here's a very good example how the standards help. And this is, I think I'm going to finish with this one, where we start having the code for BPVC, boiler pressure.
Right.
Code. It started in 1900. And look at the steam pressure that we used to have.
What are we seeing on the axis? Just to get started.
Yeah, this is the boiler explosions in the U.S. These are all the explosions in the U.S. And here is the steam pressure that we had. So it was around Uh-huh. It was here in the 1900s when you start having a lot of accidents with the steam pressure around 400 psi.
Yeah.
It went up right here, and now with you have all the codes and regulations, now the steam pressure keep going up, but now your accidents are going down.
Hmm.
Why? Because we're following standards, because we're following codes, because we have procedures, because we're being more accurate, because there is more precision in the projects. So at the end of the day, this is the result of everything that we're doing in our piping systems, and the decisions that management and the responsibility of each one as engineer have when you perform a project. So
Right.
I think that would be it for today. I think
That's
we pretty much covered everything that I had. And well, I apologize for being a little bit too long on the presentation
no
or
worries.
on the
No worries.
conversation.
I mean, first
And
of all, Juan, I mean, that was a very interesting plot. Thanks for sharing. It's always nice to see some historical data, and um, it shows at least that we're on the right path, right? So I like seeing that. I mean, Juan, thanks for sharing. You have a lot of angles to discuss and experience. It was a blast to have you on, and I hope to have you on the future. We speak on a regular basis, of course, and I always find it fascinating, to touch base on like technical issues with you. So let's keep on doing that and doing it in a public setting every now and then. And I also like to thank everyone who joined us today. Thanks for watching. Thanks for joining the chat. I must say there were some pretty interesting comments going on, which I tried to address in the conversation as well. But I was happy to see that also some conversations sparked off in the chat itself. So thanks for that. Again, I invite all of you to connect with me and Juan on LinkedIn. Feel free to have a look at engineeringtrainer.com. We have some courses for free, one of which is related to pipe stress, and of course to the Stressman Engineering course itself. Having said this, Juan, I'm not sure, like, what is the time on your end?
it's what time is it here? It's 11:30. 11:30
11:30
a.m. Yeah,
a.m.
11:30
Exactly.
a.m.
All right.
a.m.
So
Yes.
have a great day to you. You have almost the full day ahead of you. Here in the Netherlands, it's 5:30 p.m. So we're moving towards the evening. Have a great day, Juan, and to all people in the chat. Thanks for joining, and have a great day or evening or night.